Good morning. Today we will start with the lesson 3 in the unit 1. It's called about the main groups in the modern periodic table. We study the modern periodic table and we know that it consists of period and groups. But today we will study the main groups in the modern periodic table. They are three and we will talk about its properties. The three main groups are 1A, traditional name, and in the modern it's number one, halogen. 7A group in the traditional number, but 17 in the modern number. Inert gases or noble gases, that is in group 0 in the traditional number, but 18 in the modern number. So the three main groups that we will study in this lesson. 1A is called alkali metals, 7A or 17 called halogens, 0 group or 18 group is called inert gas. We will talk about each group and what its properties, what the difference between them and their properties. We will see the modern periodic table. This is coloring. The hydrogen is non-metal. It's non-metal. The pink color from lithium to francium, they are alkali metal, group 1A that we will talk about it. After that, they are metal, other type of metal. The yellow color there, and here they are called transition metal. Transition metal. This color, it's type of metal. Type of metal. Other type of metal. The dark yellow color is called metalloid, and we studied it in the previous lesson. This is the brown color is non-metal, some of non-metal. This is the purple color here are halogen. So 7A or 17 group is called halogen that we will study it. The pink color, this is alkali metal, 1A group that we will study it in this lesson. And the green color, this is a noble gas or zero group that we will also study it. So the three group that we study in this lesson, the pink color alkali metal 1A, the purple color 7A or 17 halogen, and the green color is the noble or inert gas, 0 or 18 group. We will talk about the first group, alkali metal, and we will know why it's called the alkali metal. Group 1A or one in the modern periodic table, it's called the alkali metal. Where its location? As we see, it's located in the maximum left side of the table. It's located in the maximum left side of the modern periodic table. This is the pink color. All of them are metal, except one element, that is hydrogen, is not related to the 1A group. Hydrogen is non-metal and it has different properties than the previous element. So all group 1A metal or alkali metal except halogen, which have different properties than them because the halogen is non-metal. And all of them solid except hydrogen is gaseous. So group 1A alkali metal, all of them are metal except hydrogen, which is non-metal and they have different properties because it's gaseous, but all the 1A group are solid. And it's located in the maximum left side of the modern periodic table. What about the physical properties? We know that each element has physical and chemical properties. Physical properties, how it's like its shape, its state, solid or liquid or gas, its density. This is all about melting point or boiling point. There are all physical properties, but chemical properties, how it's reacted with oxygen or water or any other element. We will study its physical properties. Group 1A or alkali metal are all of them metal, and we know the metal is good conductor of heat and electricity. All the metal are good conductor of heat and electricity. So the 1A group or alkali metal are good conductor of heat and electricity. When it's used, it connects the heat or electricity. Are all of them are solid. From lithium to francium are solid, except not an except. Okay, يبقى so in the alkali metal are good conductor of heat and electricity like all metal. All of them solid except the hydrogen. We say the hydrogen in the 1A group, but not related to this group because it's non-metal. All alkali metal elements are have low density, have low density. Density meaning it's smooth or thin in the liquid they are putting in it. As we see this figure, this is the density of 1A group elements from lithium, sodium, potassium, rubidium, and cesium. So the element that we will study in 1A or alkali metal, lithium, then sodium, potassium, rubidium, cesium, and francium. They are 6 elements. As we're moving in the group 1A from lithium to cesium, this is our the density of them. Scientists measure their density and putting them in figure or graph to study its density. As we see in this graph or figure, lithium has the least or the smallest density. Then potassium, then sodium, then rubidium and cesium. The cesium and rubidium. So the cesium and rubidium are the largest density in 1A group, but lithium, sodium, and potassium are the smallest density. So group 1A, the first 3 elements, lithium, sodium, potassium, are the smallest density. But rubidium and cesium, the last 2 elements, have large density or high density. But as we order the density from lithium to cesium, lithium number 1, lithium number 1, potassium number 2 in density, then sodium number 3, then rubidium number 4, and cesium is number 5. These are the order of density from the smallest to the largest density. And we see lithium, sodium, potassium are the low density. So they are float on the water surface. So we call it has a smaller density than water. Why the rubidium and cesium has higher density? Because it's sink in the water. So the 1A group, alkali metal are has physical properties. They are good conductor of heat and electricity. All of them solid. All of them solid. So the alkali metal 1A group, its physical properties, they are good conductor of heat and electricity, all of them solid and having metallic cluster. Most of them have low density except rubidium and cesium. Order the element according to density, number from the smallest to the largest in group 1A. Lithium has smallest density, then potassium, then sodium, then rubidium and cesium. The first three elements, lithium, sodium, and potassium, have smallest density, so it's float on the water surface. Rubidium and cesium has large density, so it's sink in the water. This is about the physical properties of the group 1A or alkali metal. What is about chemical properties? Chemical properties. How it's reacts, how it's enter chemical reaction. We know that the group 1A, it's called 1A because it has one electron in the outermost. Because it have one electron in the outermost. So all 1A group has one electron in the outermost, so they are called monovalent. Monovalent meaning it's lose one electron during chemical reaction. So all group 1A have one electron in the outermost, and when into chemical reaction, it's losing the one electron or the valence electron or the electron in the outermost, and it changes to positive ion, carry one positive charge. So when the group 1A enter chemical reaction, it's enter chemical reaction to complete the outermost with electron. So because it has one electron in the outermost, they tend to lose their valence of outermost electron and change to positive ion, carry one positive charge because it lose one electron. Group 1A are very active element. It's the most active element in all the table. So when it's exposed to the air, it reacts instantly as it's exposed to the water vapor. So we doesn't keep it without any substance to stop this reaction. So when because they are very active element, we can't leave it without cover. So how we stop the reaction with the air? We kept it under liquids. Not any liquid. Liquid doesn't react with it. Like kerosene, it's liquid that use from benzene structure, from benzene derivative, or paraffin oil. So the alkali metal are very active element in the all modern periodic table. We don't leave it as itself in the air because it will react and make a fire and exploding. So we keep it under liquid that doesn't react with it, like kerosene liquid from benzene derivative or paraffin oil. Lithium and sodium and potassium are kept under not the same liquid. Sodium and potassium kept under kerosene surface. So we put it under kerosene. They are sink in kerosene. So we keep it, and when we want to use it, we get out one of this metal and use it only. But the lithium found it's floating on the kerosene surface. When the lithium put in kerosene, it's floating. This is not useful because when it's floating on the kerosene surface, it reacts with the air because one of surface is exposed to the air and it will make a fire and react with the water vapor and the oxygen gas. So when we kept this element in liquid, it must sink in it, not floating. So we kept lithium under paraffin oil, but sodium and potassium we kept it under kerosene. So all the alkali metal kept under kerosene except lithium kept under paraffin oil because the lithium are floating in kerosene but sink in paraffin oil. So why they ask me? They are a very, very active element. Why we kept it under kerosene or paraffin oil to prevent its reaction with moist air. Moist air meaning the water vapor in the air. We kept sodium and potassium in kerosene because it sank in it, but lithium kept under paraffin oil because it's floating in kerosene. So all the alkali metal are monovalent because when enter chemical reaction, it loses the valency or outermost electron and change to positive ion carry one positive charge. Kept under kerosene or paraffin to prevent its reaction with moist air, water vapor in the air. The scientists found that the alkali metal reactivity or activity are increased as we moving down. So the very active element in group 1A is lithium, and the largest is cesium. So as we moving down from up to down in the 1A group, the chemical activity increase. This is small activity and sodium, potassium more reactive than sodium, rubidium more reactive than potassium, and the cesium is the most active element in the 1A group. So why the chemical activity increase as we moving down? Because as we moving down, the atomic number increase, so the atomic size increases. When the atomic size increase, what happens to the electron when the distance between the nucleus and the mass? As we see when we doing the electronic distribution, lithium 3, so has 2 in K, 1 in L, potassium 19, so has 2 in K, L has 8, M has 8, and N has 1. So lithium has 2 energy level, but potassium has 4 energy level. So the distance between the nucleus and the electron outermost in the lithium shorter, but the distance between the nucleus in potassium and the electron outermost are more larger. When the distance increase between the nucleus and the valence electron, the, the attraction force between them decrease. So why the chemical activity increase as we moving down? Because the atomic size increase. So attraction force between the nucleus and electron outermost decrease as the size increase. So it can lose the outermost electron more easily. When the electron outermost very far from the nucleus, it's easily to lose it than lithium. So the chemical activity increase. So why the chemical activity increase as we moving down? Because the atomic size increase, so the ability to lose the valence electron become easy. So the cesium is the most active element in the modern periodic table, and the most active element in the modern periodic table because the largest atomic size, so it loses the valence electron in this. This is about the chemical properties of 1A group or alkali metal or alkali metal. How the alkali metal reacts? How the alkali metal react? We make experiments between sodium and potassium, and we see how the reactivity increase as we moving down in the group. We put sodium and potassium in a different beaker and putting water in it. So Okay, we getting two beaker, putting in them water, putting pieces of sodium in one and potassium in the other. And what we will see as it's exposed to water and putting it in the water, it reacts very strongly and making a fire with pop sound. But we see the fire in potassium reaction more than in sodium. That's mean the potassium is very reactive than sodium because it make fire more than sodium and it reacts strong. So all the alkali metal group react with water, but the activity different. As we see potassium and sodium, what we observe in this reaction, potassium react strongly than sodium with water. But each of them, when react with water, forming alkali solution and the hydrogen gas evolve with pop sound. So why this reaction make a pop sound? Because the hydrogen gas is evolved that is responsible for the pop sound. And alkali metal formed, sorry, alkali solution formed, so we called it alkali metal. So why we call this group alkali metal? Because when it reacts with water, forming alkaline solution. Alkaline solution, from this name, it's called alkali metal. And the pop sound that we hear from the hydrogen gas that we call. So when the sodium reacts with water, sodium hydroxide alkaline solution formed, and the hydrogen gas evolved with pop sound. But when the potassium reacts with water, it also forming the same product, but potassium hydroxide alkaline solution and hydrogen gas evolve with pop sound. But the difference, the reaction with the water is stronger than the sodium with water. Why? Because the potassium more reactive because it has large size than sodium. And so we see in the previous page the activity of the metal related to its size. When the size increase, the activity increase. So with because the potassium is more atomic size than sodium, so its reactivity increase. So when they ask me why the reaction of potassium with water stronger than sodium, because the potassium has more large atomic size and more active. And why we call it alkali metal? We said become this name coming from when react with water forming alkaline solution. Why is sodium fire we don't put off with water? We know that any fire put off with water, but the sodium fire don't put out or put off with water. Why? Because sodium and potassium when react with water, it reacts instantly, suddenly, as soon as exposed to water, strongly, strongly, and form the alkaline solution and the hydrogen gas evolved with hot sound. This reaction produces heat, so it's not a fire. So when it's not a fire, we don't need to put in extra water, so the fire will increase. So why we don't put off the sodium fire with water? Because the sodium reacts with water, forming hydrogen gas, pop sound with a fire, and alkaline solution of sodium hydroxide. This reaction produces heat and they make a fire, so don't put out by water, so the fire increase. This is all about the alkali metal 1A group or 1 group. We will talk about the second main group, 7A or 17 group. It's called halogen. It's called halogen. They are starting from fluorine, then chlorine, bromine, iodine, acetylene. Fluorine, chlorine, bromine, iodine, acetylene. They are 5 elements in the halogen group 7A or 17. The 1A located in the maximum left side of the table, but halogen 7A or 17 group located in the right side, not the maximum right side. No, in the right side before inert gas or halogen gas. The alkali metal located in S block, but halogen located in P block. Halogen, fluorine, bromine, iodine, acetylene. The right side before the inert or noble gas located in B block. But its physical properties. We say that the metal or alkali metal good conductor of heat and electricity. But the halogen is non-metal, so it's bad conductor of heat and electricity. We see that the alkali metal are solid and have metallic cluster, but the halogen, some of them gaseous, like fluorine, chlorine, has green color gaseous. The bromine is a liquid, red, dark red color liquid, and the iodine is a solid. So the halogen has the three states: gaseous and liquid and solid. The solid is the liquid iodine, bromine is the liquid or the only non-metal liquid. The fluorine are gaseous states. What about chemical properties of halogen? We see the alkali metal have one electron in the outermost, so could hold it monovalent. But the halogen have 7 electrons because it is group 7A or 17. So it has 7 electrons in the outermost energy. But when it enter chemical reaction, it also tend to gain or not lose. So the metal when enter chemical reaction, it lose 1 electron. But the halogen, it tends to gain 1 electron and it change it to a negative ion, carry also 1 negative charge. So the alkali metal have 1 electron outermost, so it's called monovalent, and also the halogen is monovalent. But we'll see why the halogen is monovalent, because it tended to gain 1 electron during chemical reaction and they carry one positive negative, sorry, 1 negative charge. 1 negative charge. But why the alkali metal are monovalent? Because it tended to lose 1 electron to the chemical reaction, uh, forming positive ion carry 1 positive charge. So the halogen alkali metal are monovalent. The halogen, so the alkali metal are monovalent because it tends to lose 1 electron or the valency electron and they change to positive ion carry 1 positive charge. And all the alkali metal elements are the monoatomic. Monoatomic. They are monoatomic. Monoatomic because it's found as one atom. These elements are found as one atom. Lithium, small, its element or molecule consists of one atom. So the alkali metal are monovalent and monoatomic. Monovalent and monoatomic. But the halogen, also monovalent but diatomic. But diatomic. So the halogen are monovalent because it gain 1 electron, change it to negative ion, carry 1 negative charge, but they are diatomic, mean its molecule consists of 2 atoms. Molecule consists of 2 atoms. Fluorine found at F2, 2 atoms of fluorine, chlorine FCl2, bromine Br2, iodine I2. So it reacts with two atoms, not single atom, a monoatomic molecule like alkali metal. And the halogen are bad conductor of heat and electricity. Bad conductor of heat and electricity are some of the gases like fluorine and chlorine. Bromine is a liquid, iodine is a solid. They are chemically active, like metal, like alkali metal. They have activity like alkali metal, but alkali metal is the most active element in all the modern periodic table. All the halogen are diatomic, except acetine, because the acetine is artificial prepared. Fluorine and chlorine and bromine and iodine is found naturally in the is found naturally. It's found in nature. But the acetine is the only halogen that prepared artificially. Scientists prepared it, not found in nature. So this is today all about we have a study in this lesson. We study two of the main group, 1A group called alkali metal, and we study what is the element that found in 1A group, and what's name, its physical and chemical properties, why it's called alkali metal, and how it reacts with water, and what's chemical activity. And we study the halogen, its location, where the block, its physical properties, and some of chemical properties. Next session, we will complete some of chemical properties of halogen, and we will study the Nobel Belt or we will continue. Thank you.